drop a like and do share. Leave your comments and do not forget to subscribe for more videos.
Hello and welcome to Edupedia World.
Dear students, in this video we will study about the chapter Hydrocarbon. First see the contents. First we will deal with the general introduction. Then we will study about the alkanes, their preparation and properties. Then we'll also study about conformers. Okay, they are different from isomers. In previous chapter we have studied about isomers. Here we will see another phenomena associated with alkanes, that is conformers, and it is only associated with alkanes. Okay, then we'll study about alkenes, preparation and properties. Similarly, alkynes, preparation and properties. Then we'll also study about aromatic hydrocarbons, and lastly carcinogenicity and toxicity. Okay, so let's start. First, what are hydrocarbons? So hydrocarbon is made up of two words, that is hydro and carbon. So hydro means hydrogen and carbon is, so the hydrocarbon, they should have hydrogen in it and carbon. So we'll define it as hydrocarbons are the compounds containing only carbon and hydrogen. So here, as you can see in this ball and stick model, that the blue balls, they are carbon atoms, okay, and these gray ones, they are hydrogen. Okay, so the carbon and hydrogen will be bonded to each other by a single bond, because hydrogen can form only one bond, whereas these carbon, they can be associated with each other, okay, either by a single bond, double bond or triple bond. So on basis of this they can be classified. Okay, so next is the classification of hydrocarbons. Okay, depending upon their carbon-carbon bond, okay, they are classified as, first is saturated hydrocarbon, then unsaturated hydrocarbon, and lastly the aromatic hydrocarbon. Okay, this model shows the carbon atom is there, then the electron shared between these carbon, and this is the electron cloud. Okay, so first let's start with the saturated hydrocarbon. So in saturated hydrocarbon there will be only single carbon-carbon bond. Okay, so this is the key word, that they will have only single carbon-carbon bond. Okay, so the single bond, they can be as open chain, okay, or they can be as cyclic ring. So we again classify them as open chain hydrocarbon or closed chain hydrocarbons. Okay, and why do we call them as saturated hydrocarbon? Saturated means something which has achieved its maximum capacity. So maximum number of hydrogen that can be attached to any carbon atom has been achieved. That's why they are known as saturated hydrocarbon. Okay, for example, see here, carbon, maximum only 3 hydrogen can be attached, because carbon can form only 4 bonds. Okay, similarly, like you can see here, 1 and 2, these bonds have been formed, so maximum 2 bonds can be formed with hydrogen. Okay, so if maximum number of hydrogen is attached to the carbon, then it will be known as saturated hydrocarbon. Now we have earlier seen that either they can be open chain or closed chain. So if the ends of the carbon, they are not joined, then they will be open chain. Like The ends are not joined, so they are open chain and they are known as alkanes. For example, this is the isobutane or 2-methylpropane, as we have done in the previous chapter regarding the IUPAC nomenclature. So you can also refer the previous chapter regarding the IUPAC nomenclature. Okay, and also about the common names. Similarly, if the ends of the carbon atom they are attached, then it will form a closed ring or a closed chain, and it will be known as cycloalkanes. For example, cyclopentane. Okay, you can easily verify that each carbon is linked to another carbon to form a chain. Okay, and all the carbons they have maximum number of hydrogen which could be attached to it. Like each one is having 2 bonds with the carbon, so maximum 2 hydrogen can be attached to each of the carbon. So saturated means the maximum number of bonded hydrogen attached to the carbon atom. Next, unsaturated hydrocarbon. Okay, so obviously they will not have the maximum number of hydrogen which can be attached to them. Okay, so how the valency of carbon will be satisfied? So valency of carbon will be satisfied by multiple bonds. So unsaturated hydrocarbon will contain carbon-carbon multiple bond. Okay, so either they will have double bond or they can have triple bond, because carbon can form only 4 bonds and carbon-carbon 4 bond is not possible. It is not symmetrically allowed. Okay, so if the hydrocarbon they are having multiple carbon-carbon bonds, so they will be called as unsaturated hydrocarbons. So depending upon the multiplicity of the bond, they are classified as alkenes or alkynes. Okay, if they are having at least one carbon-carbon double bond, then they will be classified as alkenes. Okay, ENE. For example, ethene. Here we can see that carbon is having a double bond among themselves. Okay. Similarly, if they will have at least one carbon-carbon triple bond, will be there, then it will be alkynes, YNE. Okay, for example, ethylene. And as we have discussed, carbon cannot form 4 bond with each other. Okay, because there is S and P, no d orbital present on carbon. Next, aromatic hydrocarbon. This is special case, and in this kind of hydrocarbon there should be at least one aromatic ring. Okay, so we have also discussed about this aromatic ring in great detail in our previous chapter. You can refer those videos. Here we will just summarize what is aromatic ring. Okay, so any hydrocarbon which satisfy Huckel rule is known as aromatic. Okay, and in Huckel rule there are 3 criteria. First, that is, this should be cyclic, conjugated, and satisfying 4n plus 2 5 electrons they should have. Okay, so since it is cyclic, so it will obviously be a ring. Okay, and then it should be conjugated. What do you mean by conjugated? Conjugated means alternate single and double bond. For example, here we can see double bond, single bond, double bond, single bond, double bond. So this is cyclic, then alternate single and double bond, so it is also conjugated. And third criteria was 4n plus 2 pi electrons. Okay, so if n is equal to 0, then 2 pi electrons. If n is equal to 1, so 6. If n is equal to 2, then 10. So let's count here. This is the pi electron, but the single bond is formed by sigma bond. Okay, here it will be a sigma bond. This single bond is also sigma bond. Okay, and double bond is formed by a pi bond, or triple bond is also formed by another pi bond. Okay, so this is pi electron, this is also pi electron, and this is pi electron. So total how many pi electrons are there? It is equal to 2 plus 2 plus 2, 6. So here we have got 6 pi electrons. So it is satisfying all the three criteria. So it is satisfying the Huckel rule. It is cyclic, it is conjugated, and it is having 6 pi electron. Okay, so it is aromatic, and we will say it as aromatic hydrocarbon. And the simplest aromatic hydrocarbon is benzene, and these all are derivatives of benzene. We have discussed regarding benzene in great detail in our previous video. Please refer those video if you have any confusion related to aromatic hydrocarbon or aromaticity. Okay, so it is known as toluene. Okay, and similarly this one is xylene. One type is ortho. So if the adjacent positions are occupied, then it is known as ortho. If that is 1, 2 position, if 1 and 3 position will be occupied, it will be known as meta. And if 1 and 4 position will be occupied, these 2 positions, then it will be known as para. Okay, so similarly this is ortho. If I attach CH3 here, then it will become meta. If I will attach CH3 here, this one, then it will become para. Okay, so this was one type of aromatic ring in which benzene were there. Okay, similarly we can have aromatic compounds in which there can be more than one benzene ring. For example, naphthalene, there are 2 benzene rings are fused to each other. Okay, similarly anthracene, here 3 benzene rings are fused to each other. Okay, so if it is containing at least one benzene ring, then they are known as benzenoid. Okay, benzenoid. This will be benzenoid. There are also another type of aromatic hydrocarbons which do not contain the benzene ring, and they are known as non-benzenoid. Okay, for example, urine. And in this type there will be a heterocarbon atom. Okay, so apart from carbon and hydrogen, there will be other element. So they are not hydrocarbons. That's why in this aromatic hydrocarbon there will be only benzoid. There will be no non-benzenoid. I just refer it so that you have a clear picture about the aromatic ring and aromaticity. Okay, so apart from this benzene type of structure, there are also other non-benzenoid structure which are also aromatic, and you can refer to the previous chapter video related to aromaticity. Okay, so let's summarize the types of hydrocarbon. First, it is saturated hydrocarbon, that is alkanes, and they will not contain any double or triple bond. Okay, for example, propane, methane, ethane, whatever. Okay, so ane will be the suffix. Similarly, there are unsaturated hydrocarbons, two types, alkenes and alkynes, ene and yne. So if it is having double bond, then it will be alkene. For example, propene, that is having one double bond. Similarly, alkynes, triple bond. It should have at least one triple bond. Propine, C triple bond C. Okay, and lastly, aromatic hydrocarbon. So in aromatic hydrocarbon, there will be aromatic ring, and preferably it will be benzene type of structure. Okay, because in non-benzoate structure there will be one heteroatom and it will no longer be a hydrocarbon. So benzene, Huckel rule, cyclic, conjugated, and 4n plus pi electrons. Okay, this is methyl benzene, or common name is toluene. Thank you.